Hey everyone, and welcome to this virtual Eclipse community meetup. Today we're joined by Sravan Lakkimsetti, who's going to be taking us through his presentation. So I'll leave it over to him. Go ahead.
Thank you. Hi, this is Sravan. Let me start my screen. Okay. Hi, welcome to my webinar on migration to JIRO. I am Eclipse Platform Project Co-lead as well as committer on Eclipse Equinox and JSJ projects. I have been handling release engineering for platform projects from quite some time. So this is one of the new tasks which came up recently to handle hardware better. Let's see what we overview of release engineering at platform project. In Eclipse uses a couple of tools for release engineering. One is Jenkins tool, which is a continuous integration and continuous delivery platform. As you see from the Eclipse point of view, we have this is one of the Jenkins instances. These are list of jobs. As you can see for each release engineering activity, there is one particular job, and these jobs run on a executor. These are all different types of executors which are available on a Jenkins instance. This automates the schedules and automates your release engineering activities. Now, another job which we use is Gerrit. This is used for code review and verification of patches. This also includes a Jenkins job for verification of patch. So now let's see how Gerrit job works. In the typical flow of a code patch, end user submits a code patch. You can see that code patch in this particular website. This is actually called, this is a Gerrit website. You can see these are all different code patches. And for each patch, there is a new validation job which runs on Jenkins. If you see any of these jobs, let's see one of these jobs. In this, you can see there is a Gerrit validation job link. If you open this, here it runs a Gerrit validation job, which the first thing which it does is it compiles the code, and then if configured, it runs a unit test on that particular code. And once that is done, you can see a verified +1 or -1. Then another user can commit, or he can give his review comments on top of this code. This is how normally Gerrit works. In this particular thing, we have Jenkins involved in both cases. First for creating builds, and second for doing validation jobs. Now let's see. That's an overview of a build infrastructure which we have, which is relevant to us for this presentation. Now, if you see the world build infrastructure, we have 5 different Jenkins instances for the platform projects. There are four Jenkins instances for each of Equinox, PDE, JDT, and platform. And there is one more Jenkins instance called Releng instance. This is used for creating builds and managing the download.eclipse.org website, where we publish our releases. Now, in case of Jenkins instances for Gerrit builds, all the builds run as a Maven build in the local job workspace. You can see them here. We have, if you see this Equinox, we have different jobs. These are all, this is for one of the repository called P2, RT Equinox P2. This is the repository. For this, you have, these are different validation jobs. All these jobs run on the workspace itself. Then we, once a workspace is built and unit tests are run, and if the unit tests are successful, we get a verified +1 on the Gerrit patch itself. Now, this is the same case for Equinox, PDE, JDT, and platform. And in case of Jenkins instance for Releng, this is somewhat different. Here is a Jenkins instance. In this case, it has multiple jobs. Like we have builds. These are different jobs to build types of builds. Like one job here, it says create source bundle. So we supply source bundles in our builds. Like let's see. If you see any of the build here, there is, we provide source bundles here. This is created by this particular job. Like this, we have different jobs. This iBuild job is used to create these iBuilds, and we have tests, then native build jobs, etc. In the old infrastructure, we have a storage server called build.eclipse.org, where we used to store build artifacts and copy them only the relevant information to download at eclipse.org. Now, after that, since test requires UI tools, we have custom machines. Actually, these are physical machines which are connected to this chip. Like if you see this slave one, this is a Linux test machine like this, and here Mac OS 10.14. This is a Mac OS test machine. Like this, we have multiple machines attached, and these are all need to be maintained by the foundation. So then we have SWT and launcher build. SWT and launcher have native components which are built on C, C++. These can run directly in the target OS. These don't require a Java virtual machine to be installed. So these parts will have custom tools, basically C, C++ build tools, and also required development libraries to be installed on the build systems. For this, we need to have custom machines like RHL71. There is another one called here Fedora 28 PPCLE. This is also one of the machines. Windows Server. This is also one of the machines. Like Mac OS 12 is one of the build machines for the native builds. Now, this becomes pretty tough for foundation to maintain. And if you see the list of Jenkins instances, if you can see, these are all the Jenkins instances foundation maintains for Eclipse projects. Apart from this, there is one more Jenkins instance which is called a shared. Now, what happens here is it becomes pretty hectic for foundation. Now they came up with a solution called JIRO. This is Jenkins instance running on OpenShift. So let's see what is JIRO and why we need JIRO. Okay, JIRO stands for Jenkins instance running on OpenShift. OpenShift is a private cloud platform developed by Red Hat, It runs on-premises cloud architecture. Basically, you can add multiple machines to OpenShift cluster, and each Jenkins job creates its own pod, and job runs on top of that particular pod. For this pod, you can specify your own custom Docker image as well. So, like if you see this, we have Red Hat 7.1 machine, custom machine. This this we can convert to a Jenkins job running on CentOS 7.x pretty easily. If you convert, if you can create a CentOS Docker image, you can pull that Docker image and run it in a container. That becomes a machine for your SWD build job to run. That kind of facility this provides. This also provides resiliency. Scalability means we can add as many machines as you want to OpenShift cluster. OpenShift will start using distribute all the resources across all the projects. So since resources are getting expanded, we'll have a little bit faster build times as well. So because of more number of Jenkins instances required and more number of resources requested day in, day out, Foundation has to scale up. They have to scale up current infrastructure. Then they have to utilize hardware better. Like if you see, in this case, if you see this Releng is on HIP 8, this is one server where Releng is running. Similarly, there are multiple Jenkins instances running on the same server. What happened here is, because Releng is a huge one, other servers will be short of resources here. So that kind of problem has to be sorted out. Foundation has to limit project resource consumption and provide isolation. Then, as I said, Jenkins running on OpenShift, and it runs in a pod, and pod actually hosts a container. So since it is a containerized environment, we can provide more flexibility to projects. Basically, we can offload maintenance of build systems to teams. A team can create their own custom Docker image and upload it to Docker Hub. They can pull that particular Docker image and use it for their Jenkins jobs. So with this, we do have some restrictions imposed in the JIRO infrastructure. So the first one, we have security changes. There are multiple security changes we got. First one is, as I said earlier, in the old infrastructure, everything used to be stored in build.eclipse.org. That is gone now. So we have to store everything on the Jenkins workspace and copy everything onto download.eclipse.org. Earlier, we used to copy builds using NFS share. So simple CP command used to work there, but now it is not possible. You need to use SSH or secure copy, secure shell or secure copy. So build scripts have to be rewritten for this purpose. Then other problem, because it is a containerized environment, we have some issues with that. The first one is Java. Java 6 and below are not optimized for containerized environments. So most of since Eclipse supports Java 8 and above, we had to move our projects to Java 8. Then another feature we we used to use pretty heavily is once the job is completed, workspace used to be retained. So we used to access artifacts from the workspace directly from subsequent jobs. This is not possible anymore because the workspace is created in the specific pod where the job ran. So once the job is completed, pod gets destroyed. So along with that, workspace also gets destroyed. So you don't have that access now. So we have to rework our job architecture as well. Then we have resource restrictions. Earlier, we used to have multiple build executors. Build executor is like one process. How many jobs you can run simultaneously. Basically, if you see this is a master node. On this node, you have 5 different executors. These 5 different executors means you can run 5 different jobs simultaneously. That is not possible now with JIRO. So by default, we will get only 2 executors, and these 2 executors also you can run up to with a CPU of 2 gigahertz and 4 GB of RAM. You can still increase these executors, but you need sponsorship from Eclipse Eclipse members to get more executors or dedicated agents. Dedicated agents are the ones like if you see this in this case for Windows and Mac, we don't get a Docker image. So for these, we still need to connect physical machines. If the foundation provides a machine for these ones, those are called as dedicated agents. Otherwise, if end users can, if projects provide their own machines, those are also called dedicated agents, but they are not counted against corporate sponsorship. If foundation provides those machines, then only dedicated agents are counted against corporate sponsorship. But we need dedicated agents for Windows and Mac because we will not get, we won't get Docker images for those. Same case with different architecture. The machines we have at Foundation are x86 architectures. So if you want to test on a different architecture like Power 8 or G systems, then you need to connect your own machines there. Next problem we have is platforms I build requires 6 GB of RAM, but only 8 GB is provided for each executor. So we have to come up with a custom pipeline with our own a custom pipeline with our own memory allocation here. I will show you that how we did it. Okay. Here. This is the iBuild job. We have a custom pipeline script. In this, under the resources, we specify how much memory should be allocated for this job and how much CPU should be allocated here. This is how we do this. Then we have native builds and tests that require custom tools. Test requires UI tools to be installed. So default agent will not be sufficient for our tests. Current default agent is called as migration pod template. That will work now. When we started this work, that was not sufficient for Eclipse platform testing. So we actually provided what tools needs to be added to the migration pod template, and Foundation added them. So for tests, you can run migration pod template that runs on CentOS 7. If you want to use different operating system like CentOS 8 or Ubuntu, you need to have your own custom a custom Docker image. We also do that in here. So we run multiple jobs in different. These are all test jobs which runs on 4 different configurations. We created our own Docker images, and we pull those Docker images and run test jobs on that. Native builds and tests. Similarly, for the native builds also for Linux, we can create our own Docker images and use them. In case of Windows and Mac, we need dedicated agents. Okay. For the migration of Equinox migration of Gerrit jobs, Gerrit verification jobs, all these are for Gerrit verification jobs. We migrated using migration pod template, which is available, which is created by Foundation. This migration pod template has most of the tools required for Maven build to run. This also includes UI testing tools, so that you can use straight away. The second thing which we had to do is, because Java 7 and below are not optimized, Java 6 and below are not optimized for containerized environment, we had to upgrade our projects to Java 8, so we upgraded them. Then executors for JDT has to be increased with sponsorship from IBM. JDT jobs take more than 2 hours. JDT stands for Java Development Toolkit. They take more than 2 hours because 150,000 tests are run for every code commit. So this creates a huge queue in the JDT Jenkins instance. So for that, we had to increase executors with IBM sponsorship. Second problem we had was platform Jenkins instance has about 16 Gerrit repos being verified, and we have more than 100 committers there. So here again, because there are more number of committers who are committing patches here, we had to increase executors here also. Here with sponsorship from IBM, Red Hat, and Mozilla.com, we increased executors to 8. Similarly, on the platform Jenkins instance, we had one repository, that is SWT, which requires custom tools. So we had to create our own Docker image based out of CentOS and use custom pipeline because it uses somewhat a different build strategy there. That actually completed our migration of 4 of the Jenkins instances. If you see this, this is a platform Jenkins instance. If you see SWT, here it is. This has 2 stages. One is build and one is preparation of environment. And we had to configure using our own pipeline script. Still opening. Okay. As you can see, here is a image which we specify our own custom HWT build image. This is our own custom HWT build image, and for the preparation environment, we check out source code. Then for the build, we actually run a couple of maven scripts because HWT has two repositories. One repository is in binaries repo, and another one is in HWT repo. Both we have to build. Both we need to build and see whether our code compiles or not. So this is our custom script. This is how HWT has been migrated. Now comes the migration of release engineering Jenkins instance. This is the most complicated part. Okay, from the time taken point of view, the previous ones, all these 4 Jenkins instances took less than 1 month, and a release engineering Jenkins instance took more than 6 months. That's the amount of time it has taken. Now, this is used for creating build and promoting a build as a release. Also, it maintains a validity of old repositories. This kind of task this release engineering instance has. The first job which we started is the iBuild job. iBuild job is this one. This iBuild job is used for building an iBuild. Integration build. So this has to be rewritten because earlier iBuild jobs are using build.eclipse.org as a storage space. That is not available now. Because of that, we had to rewrite. And Kitlo from IBM had rewritten the whole scripts here. Then second step we had to do is we had to resort to custom Jenkins pipeline because as this build requires more than 6 GB of RAM. How we did it is we specify our own pipeline using a YAML. In this we specify the image which we need to use. This is the default migration agent, but with more amount of RAM and more amount of CPU. Also we divided this task as multiple steps in the build process. Alexander Kortukov from Red Hat helped us in this particular task. So we split into multiple stages. If you see this, you can see each stage listed here. You can actually see if anything fails, that particular job is listed as failed here. These are different stages which you can see. Then another problem we had was this particular iBuild also has all these test jobs as well as official test jobs to be run after the build completes. This gives actual test jobs have about 5 different configurations. 6 if you look at vBuild. vBuild is for new Java development. Then for the smoke test, you have about 17 jobs. So all these needs to be run simultaneously. So we need more executors here. So we increased the executors to 8. We run official test jobs simultaneously, but smoke tests sequentially. That way we manage to do this. And here IBM and Red Hat chipped in for the sponsorship. Then we use custom containers for the test jobs. Initially, when we started, our test jobs required more tools. So those tools were not available in migration pod template. Because of that, we had to use custom containers, and we are continuing to use our own custom containers for our test jobs. Similarly, so these are all uploaded to Docker Hub, and we use images from there. Other jobs like we have these are promotion jobs. Like once the iBuild is tested, it will be promoted as a milestone build or release build. Those kind of jobs we can see here. These jobs are like that. These jobs are used for that. All these jobs are migrated using the migration pod template. Also, some of the jobs had to be rewritten because all these used to operate on build.eclipse.org. So we had to rewrite these jobs again. Then another problem, the final problem we had to solve was how to resolve jobs which use workspace data. The kind of jobs which we had was build promotion jobs, which used to share workspace between the build promotion jobs. That is not possible now, so we had to use archives there. Then we have promotion to Maven Central. All the Eclipse artifacts, all the Eclipse platform artifacts used to will get promoted to Maven Central. So these jobs also you share workspaces. So we had to rewrite these jobs. Similarly, native build jobs. Native build jobs also have the same problem. Okay, yeah, that actually completed our Releng Jenkins instance migration. So here are the sponsored agents, sponsored resource packs and dedicated agents. Resource packs, Eclipse Foundation calls 2 executors as resource packs. So if there is a one resource pack sponsored to a particular Jenkins instance, you will get 2 executors added to that instance. So here are the sponsorship details. Yeah, that's all I have actually. Any questions from anyone? Hi.
Hey, thank you so much for presenting. It doesn't look like there's any questions. So thank you so much for taking the time to join us today. And like I said, this video is going to be posted on YouTube. So if anybody wants to watch it back, there will be a link going out tomorrow. But thank you to everybody who joined in the audience. And thank you, Sravan, for presenting.
Thank you.
Have a good one.
Thank you for your time.
Bye.